discussed about two things in the previous class. The first one was that if we have, right, so we talked about work done in external electric field, or in the presence of work done in the presence of electric field, right? And we also talked about that this electric field can be of two types: uniform and non-uniform or variable, right? So for uniform, we found out that work done is in bringing a charge from initial point to final point was what? Aisha, this was what? Yes.
Minus QE.
Yes, absolutely. Yeah, R final minus R initial. Right, so this was the work done for the uniform one. And for the variable one, work done in bringing a charge from initial to final was initial final minus Q E dot dr. Right, so this we did in the previous class. Right, Aisha?
Yes, sir.
Now let us come to this potential and potential difference. So what is potential and potential difference? So we know about potential, right? Potential is work done. Let's say work done in bringing a charge from infinity to point P is Q into V, right? So this
Yes, sir.
potential is work done in bringing a charge from infinity to point P by Q. So this is how much? Minus Q and infinity to point P E dot dr divided by Q. So Q gets cancelled and we have potential equal to minus of infinity to point P E dot dr. So this is the potential, right, Aisha?
Yes, sir.
But what is potential difference? So let's say we are, this is about what? So we are taking, this is infinity point, this is Q, and this is some point V. So work done in bringing a charge from here to here. This is the potential, right? Now what is the potential difference? So potential difference is work done in bringing a charge from, let's say, B to A point, from fixed point A to fixed point B, right? Or let me write this as A to B, right? So what would be the work done? This would be from A to B. This would be minus Q and A to B and E dot dr. Right, Aisha?
Yes, sir.
And we also know that what is the potential. So work done is Q VB minus VA. Right, so minus Q and A to B and E to dr. So Q gets cancelled and we have the potential difference as, potential difference as minus of A, B, E dot dr. So this is the potential difference. So the difference between potential and potential difference is just the points, right? Where we are taking the charge from and where we are putting that charge. So if we are taking the charge from some initial point, right, initial fixed point to final fixed point, so that would be what? Potential or potential difference? Yeah, Aisha. That would be what? From fixed point to another fixed point. So that would be what? Yeah, that would be potential difference, right?
Yes.
And if we are taking the charge from infinity to a fixed point, so that is potential. So that is the main difference between potential and potential difference. You please, oh, you have already, yeah, so you please note down this part and then we'll do the numericals based on this, these two concepts. So please note it down. And whenever you need me to scroll down the screen, you please tell. Okay, so Rabia has just okay, so she is joining now.
So you can scroll.
Yeah, so yes, Rabia, Assalamu alaikum.
Walaikum assalam, sir.
How are you? So you have joined so early. What has happened?
Sir, I forgot that I had class right now
Oh, worry.
and I was sleeping.
Oh, you were sleeping and then you got the message or the call from the Learnivio team, right?
Yes, sir. My mom woke me up saying that
Yeah,
I had listen.
yeah. So don't forget about these classes, right? Because this happens only once in a week. So, okay, that is why you forgot because it happens only. If this was a regular class, then you could have remembered. Okay, yeah, but be regular, right? Otherwise, you will miss some topics. Okay.
Yes, sir. Okay.
Okay, so first let Aisha complete this and then I will talk about what I did so far. Okay, in 5 minutes
Done,
I
sir.
will done. Okay, so yeah, as I told in the earlier class, right? So in the earlier class, I stopped at this point, potential and potential difference. So I just talk about what is potential and what is potential difference. So if you bring the charge from infinity to a fixed point and then you do some work, so that would be called the potential difference, right? Potential, not the potential difference. So this would be called potential. Okay, Rabia. So if we are bringing the charge from infinity to fixed point, so this is potential. You please take the screenshot. Okay. Yes,
Okay,
Rabia.
sir.
Yeah, take in the screenshot.
And done, sir.
And then what you do is that you bring the charge from a fixed point A to fixed point B, right? So then whatever is the work done, that corresponds to the potential difference. So this is the main difference between potential and potential difference. In potential, you bring the charge from infinity to fixed point, and then in potential difference, you bring the charge from one fixed point to other fixed point. Okay. So let me okay, I will talk about that later. So yeah, did you understand, Rabia?
Yes, sir.
Okay, so now we can have again. So potential difference is what? Let me write it this way: V final minus V initial would be minus of initial to final E dot dr. Okay, we can write this as E dot dl, and then we will write. Okay, so this we know. Now again, the same analogy that we did in the work done. So this can be of two types, right? One would be that this is uniform, and the other would be that this is variable. Okay, so we can have two kinds of electric field, uniform and variable. So what will happen if we have uniform electric field? So what would be the potential difference? So for the case of uniform one, the potential difference is simply as we did in the work done. So this would be minus of E dot R final minus R initial. So this would be the potential difference. Okay, guys, understood? Yeah. And for the case of the variable one, for the case of the variable one, V final minus V initial would be, yeah, minus of I F and E dot dl. So please note down this part. Uniform and variable. Please note down this part. And whenever you guys have completed noting, please tell. Yes, noted, guys.
Yes, sir.
Yes, Aisha, noted. Yes, Aisha, noted. Okay, you are you there, Aisha? Yeah. So okay. Now let us do some question based on this. So we want to calculate. Question is that what is the potential difference in bringing a charge from A, which is let's say 2, 3, 4 to B, which is 1, 2, 3 in the presence of, let's say, electric field, which is 2I plus 4J plus 3K. Right. So what is given, guys? What is given? R final is given, or let me write, R initial is given, which is R A. So how much is that, Rabia? How much is RA? Yes. How much is RA? Yes. Yes, guys. Rabia, how much is RA? Aisha. Yeah, you are not audible, Rabia. Maybe there is a
I
problem. Yeah, what did you say? Yes, Aisha. Yeah, Rabia. What did you say? What are you saying?
So is it 2I plus 3J
Your
plus
voice,
4K?
yeah, 2y plus 3j plus 4k. So your voice is breaking somehow. I guess there is a network problem. And what is, Aisha, what is our final? Yes, Aisha. Yeah, so, okay, your voice is also not audible. Is there a problem with my internet? Can you guys hear me properly? Yeah. Am I audible to you guys clearly?
Sir, my internet was not working properly.
Okay, both of you guys, yeah, both of you guys. So your internet is not. Yes, correct, Aisha. I thought that my internet is not stable, but you guys. Okay, so now we know R initial, R final, right? And we have to calculate V final minus V initial, which is VB minus VA. So this is what? Oh, but before I go to that question, what is this electric field? Uniform or variable? Aisha, what is this electric field? Uniform or variable?
Uniform.
Uniform. Absolutely correct. So this is uniform. Then we will use the this one formula. So E dot R final minus R initial, which is minus E dot RB minus R. So VB minus VA would be how much? E 2I plus 4J plus 3K and into you guys calculate and tell me the answer. So I plus 2J plus 3K minus 2I minus 3J minus 4K. So you guys calculate and tell me the answer. Okay, you guys please calculate. Yeah, so you guys please calculate and tell me the answer. Let me write this even further. So 2I plus 4J plus 3K dot I minus I. So minus I, 2J minus J minus K. So yeah, you guys tell me what is the answer. Yes, Aisha, what did you get? Rabia, what did you get? Yes, guys, any answers?
One answer.
Ah, done. You guys are doing. Okay, okay. So please calculate and tell me the answer. Rabia, yeah, are you
Yes,
calculating?
sir.
Yeah, yeah. Please
Yes,
calculate.
I'm calculating.
Okay. Yes. Oh, yeah. So this is you are getting a vector, Aisha. Right. You are getting a vector, but potential is a scalar quantity, right? So yes, Rabia, what did you get? Yes, Rabia, what did you get? So you see, this is a dot product, right, Aisha? This is a dot product. So this vector dot this vector. So only I dot I will survive, right? I dot I would give you 1. So this would be minus of 2 into minus 1, so minus 2. 4 into minus 1, so minus 4. 3 into minus 1, so minus 3. Right, so this would be minus of, this is minus 9. So 9 volts. Right, guys? So you will not get a vector. Okay.
Okay, sir.
Yes, Rabia, what did you get?
Sir, instead of multiplying, I was adding it. So I was
Oh,
getting the wrong answer.
oh, okay, okay. Yeah. So you guys, yeah, you guys please note down. Or did you guys already noted this question? Yeah, you guys please note down this question, or if you have already noted it down, so then please tell. Okay, noted, guys.
Yes, sir.
And Aisha, noted.
Yes, sir.
Okay, so now we have the uniform question. Now let us do the variable one. Okay. So what is the potential difference VB minus EA in carrying or charge from, let's say, 8, which is 1 minus 4 and 3, to B, which is, or let me write it as 2. To, let's say this is 1, 3, 4, or let me write it as 2, 3. In the presence of electric field, which is 2 by x cube I hat. Okay. So, yeah. What is this electric field, Rabia? Uniform or variable? Yes,
A variable.
variable one, right? So we will use the variable one. So VB minus VA would be minus of A, B, and E dot dr, right? DL, I should write. Okay. So we have 3 coordinate points. So DL would be simply dxi plus dyj and dzk. Okay. So this would be this. And let us just write the values. So this is minus, and A is what? 1, 2, 3, and this is 2, 3, 4. And E is how much? 2 by x cube I hat dot this is dxi plus dyj plus dz. Okay, so this is this. So you guys tell me what part will survive. What is the only part that will survive?
I.
I only I will survive, right? So I will get how much? 1, 2, 3, and 2, 3, 4, and 2 by x cube I dot dx is dx1. Right? Is this clear to you guys? Yes, clear.
Yes, sir.
Yes, sir.
So we will get what? So this would be minus, and only the limit of this x will be there, right? We don't have dy, dz integral, so only x limit would be there. So what is the limit of x? Yes. What is the limit of x? X goes from what to what? So this is x, this is y, this is z. This is again x, y, z. So x goes from, yes, x goes from 1 to 2, right? And this is 2 by x cube dx. So 2 is constant, so it is taken outside. And we have integral of 1 over x cube dx. So what would be the integral of 1 over x cube? You guys tell me, what is the answer? What is the integral of 1 over x cube? So Aisha and Rabi, you guys tell me, what is the integral of 1 over x cube? Okay, let me remind you again, guys, that xn is xn plus 1 divided by n plus 1. So this is, okay. Yeah, so what would be the answer, guys? Yes. Did you guys get the answer? What would be the answer?
X raised to 4 by 4.
X is to the power 4. How did you get? So remember, this is 1 over x cube. Yes, Aisha, what did you get?
Is more 2 by 2.
Root? What? Yeah, what did you get? So 1, 2, 1 over x cube. So this is x square by 2. So this is x minus 3 dx. So there would be some minus sign, right? Yes. So answer is correct, but there would be also a minus sign. So minus 2, right? This is x minus 3 plus 1 divided by minus 3 plus 1. And the limit is 2 to 1. So this would be minus 2 and x minus 2, not x square. So x minus 2, right, divided by minus 2. So this minus will cancel, and you will get 1 by 2x square. So x square will be in the denominator. Understood, guys? So you will have what? 2, and this 2 is taken outside. So 1 over x square 2, 1. So this would be 1 over 2 square minus 1 over 1 square. So 1 by 4 minus 1. So this is minus of 3 by 4 volts. Okay. Is this clear to you guys? Clear, or do you guys have any doubts? Yes. Guys, clear, or do you guys have any doubts?
Yes, sir.
Okay. So, Rabia, what about you?
Yes, sir, it's clear.
Okay, so please note it down from here, and then we will do the next question. Please note it down. And you guys practice integration and differentiation. So you guys have forgotten integration and differentiation. So you guys practice that. Yeah. So whenever you guys need me to scroll down the screen, you guys tell me. So whenever you guys have noted it down, please tell me to scroll down.
Done, sir.
That's noted, guys.
Yes, sir.
Yeah. So whenever you guys have completed it down, and there would be a test tomorrow, guys, right? So that would be on potential difference, work done, and yeah, so that would be on that too. Completed, guys.
Yes, sir.
Rabia, completed.
Yes.
Okay, so now we have a slightly different question, and yeah, so okay, so we have this these points. Okay, so we have let me draw a bigger diagram. So we have this, so 2 points P and Q, right? And this is the electric field. So this is the electric field. Oh, Sorry about my drawing. Oh, who got disconnected? Okay, so we have this kind of electric. Okay, this is the electric field, and it is making an angle 37 degree. So this is 37 degree. Okay, and this distance is 5 centimeter. Okay, so then what we want to calculate, or this is, let me write it as R. Okay, so first question is that what is the potential, and given is that, what is given? So this is given that magnitude of electric field is 2000, right? So this is Newton per coulomb. Okay, so this is given. And they want us to calculate what is the potential difference between VR to P. This is what. So what kind of electric field is this? Rabia, what kind of electric field is this? Variable or uniform? Just to tell you that these are parallel lines. So yeah, if these are parallel lines, then what kind of electric field is this? Variable or uniform? Rabia.
Variable.
So Aisha, is that correct answer? What kind of electric field is this? If I have parallel lines, right? So this is what kind of electric field? Yes,
Uniform.
uniform, right? Because the distance are the same, right? So this would be uniform electric field. If distance are different, then because we see that what is the strength of from electric field lines concept, right? The density is same. Electric field lines, we have same electric field lines in this region. So this would be uniform electric field lines, right? The strength would be same in everywhere, right? So this is a uniform electric field, right? And yeah, so we have this uniform electric field, and then for uniform electric field, what is the potential difference? This is minus E dot, this is R minus RP. So R is this point, this vector, and RP is this vector. So this will give me what? PR vector. So E dot PR vector. This is my potential difference. So now we need to calculate what is PR vector and what is electric field. Is this clear to you guys? Yeah, is this quick clear? Yes.
Yes, sir.
Okay, so let me recall you guys about the vector portion that we did. So we have a vector whose magnitude is let's say 3, and its direction is in this x-axis. So what would be this vector? Aisha, what would be this vector? Yeah, what would be this vector? The magnitude is 3, and this is in the x direction. So what would be this vector? Yes, 3i, right? So again, see here, PR vector is in the x direction and its magnitude is 5 centimeter. So what would be PR vector? 5 centimeter I hat. Is this clear to you guys?
Yes, sir.
Okay, now let us recall the resolution of vectors. So if we have a vector like this, whose magnitude is 2 Newton and this is making an angle 60 degree. So what would be this vector? Let's say this is A vector. So what would be A vector? What is the A vector? Yeah, these we did in the vector portions. So if you guys remember that part or not. Yes, remember or you guys have forgotten? Yes, guys. Do you guys remember or forgotten? Resolution of vectors. Right, guys? Resolution of vectors. So we have this vector, right? Whose magnitude is given and the angle is given. And we have to write it in the Cartesian form. So in the Cartesian form, what is the vector? Ax I hat plus ay j hat. And if this is the vector, so this would be the ax component and this would be the ay component. So what would be ax if this is 2 and this is 60? So this is a cos theta, right? This is the horizontal part. This is the vertical part. So ax would be 2 cos 60 and ay would be 2 sine 60. So this would be how much? 2 cos 60 I hat plus 2 sine 60 j hat. Do you guys remember now or yeah, understood?
Yes.
Okay, so again, let me go back to this question. So we want to calculate what is this electric field, right? But what is given? This is given. So this is 200, right? 2000. And this is 37 degree. So what would be electric field vector? Yes, Rabia, what would be electric field vector? So this is X and this is Y. So what would be electric field vector? Hmm. Aisha, what would be electric field vector? Yes, guys. So we just did this portion here. So if we have this magnitude and this angle with the horizontal part. So this angle and the this magnitude and the angle. We have magnitude and the angle. So this would be Ex I hat plus Ey j hat. But in case of here, this is j. This is minus j. So this would be minus j. So Ex is 2000 cos 37 I hat plus we have a minus. So minus 2000 sine of 37 j hat. This would be electric field, right? So 2000 cos 37 and 2000 sin 37. So if I take 2000 outside, so cos 37 I hat minus sin 37 G hat. Okay. So is this clear to you guys? Clear?
Yes, sir.
Okay, now we have to remember one thing more. So if we have an angle which is 37 degree, so always remember that whenever we have this 37-degree angle, so this is the right triangle whose base is, let's say, 4, this perpendicular is 3, and this is 5. So 3, 4, 5. Just remember this triplet. So this would be the triplet if your angle is 37 degree. So cos 37 would be how much? Aisha, cos 37 is how much? Yes. Cos 37 is how much? Yes, cos 37 is how much? Yes, Aisha. Cos is what? Base upon hypotenuse, right? So V by H. So cos 37 would be how much? 4 by 5, right? So cos is 4 by 5. And Rabia, what is sine 37? Yes, what is sine 37? Rabia, what is sine 37?
Uh, 3 by 5.
Yeah, so why are you hesitating? This is the right answer. So 3 by 5. So now we know, just remember, for if you are given this 37 degree, just recall this triplet. 3, 4, 5. Okay, so just remember this. Okay, then we have, this is 2000 into 4 by 5 I hat minus 2000 3 by 5 J hat. So this is 400, this is 400. So we will have 1600 I hat minus 1200 J hat. So this is the electric field. Right, this was the trick in this question. So they directly didn't give us this electric field in the form of, so up to this point we had this kind of electric field, but they didn't give the the electric field in this form. They just manipulated, or they just tweaked the question, right? So in this part only the magnitude was given and the angle was given. So we needed to calculate the electric field in this manner. This was the first trick. And the second was, they also didn't give the points of P and R. So they just again give the magnitude of PR, and then, so this was the idea of this question. Okay, so this is 5 centimeter, which is 5 by 100 I had. This would be in meters. So this is PR. Okay. Now we have calculated PR, we have calculated E. So VR minus VP would be how much? Then VR minus VP would be minus E dot PR vector. So this is minus of 16,000 I hat minus 1200 J hat dot 5 by 100 I hat. So only I will survive. So what would be the answer? You guys calculate and tell me the answer. What would be the answer? Calculate and tell me the answer, guys. Quickly, you guys calculate the answer. Yeah. Oh, you already calculated. So 80 again. I. Why I? Why I, Aisha? Why I? We are calculating the dot product. So do not always remember that potential is a scalar quantity. So we will only get, so I dot I. We have 1600 I dot 5 by 100 I, right? So only I dot I and then minus 1200 J dot 500. So I J dot I, this would be 0. Only I dot I is 1. So we will get minus of 1600 and 100. So this is so minus 80 only. Okay, Aisha. So just remember, I dot I scalar product would be scalar. So this is the potential difference, guys. Okay. And if so the second part of this question is, okay, I will talk about, okay, but let me first complete that and then. So this was the first part. In the second part, this is asked that what is the potential difference between VP and VR. So this would be just the opposite of VR minus VP, right? So this would be minus of minus 80, so 80. Okay. And in the third question, this has been asked that if VR potential at R is 600 volt, then find potential at P. So what is given? VP would be by VR, this we know, 80. VR is given, so minus of 600, which is 80. So VP would be 600 plus 80, which is 680 volt. So these are the three questions in this part. Okay. Any doubt up to this point, guys? Any doubt?
No, sir.
Okay, so please note it down from, yes. Yeah, so whenever you guys need me to scroll down, you guys please tell. Okay, should I scroll down the screen, guys?
Yes, sir.
Yes, sir.
Okay, so this part you just remember and yeah, so
No, sir.
okay. So whenever you guys complete, please. Yeah, so completed, guys. Yes.
Yes,
Not
sir.
okay. So now let us move on to now uh, we have completed the work done in the presence of electric field and what is the difference between the potential and potential difference. Okay. Yeah. So now the next question would be on what is happening with this. So yeah. So now we already know that potential due to a point charge, right? This is how much? This is simply k q by r, right, guys? So potential due to point charge, right?
Yes, sir.
And we also know that potential due to multiple charges, multiple charges. So this is simply V equals to potential due to individual charges, right? So this follows the algebraic sum. The potential follows the algebraic sum. So V is KQ1 by R1 plus KQ2 by R2 plus KQ3 by R3, so on. KQN by R. Right. So this we already know. Okay. And what more do we know? So there was a question, right? There was a question that I did in the class, and Amna ma'am has also done in her class, I guess. So the question was this. We have a square, and these kind of charges are kept. So 2e minus e and minus 2e, right? And the charge, or we wanted to calculate. So we first calculated the potential at this point, right? So we calculated the potential at this point. So VO, right? And I will not solve this problem. I am just reminding this problem so that you guys remember. So first we calculated the potential at VO. So this was what? This was VAO plus VBO plus VCO plus VDO. This is the potential at point O. And then we calculated the potential at this point E, right? So this distance is A, and this distance is A by 2. So then we calculated the potential at this point, which would be AE plus VBE plus VCE plus VDE. This was the potential at, right. And the last question was, so this was first question, this was second question, right? And the third question was, what is the work done in bringing a proton? Right, proton is what charge? A proton from O point to E. So this would be how much? Q of VE minus VO. Right? So this question we did in the class. And Rabia, you also did in your class, right? Yeah. Yeah, guys.
Sir, your voice is lagging.
My voice is lagging. Maybe your internet is. So, Aisha, did you hear me clearly?
Yes,
Is my okay? So maybe your internet is not working properly, Rabia. Yeah. So this question we did in the class, Aisha, right?
yes, sir.
Okay. And Rabi, in your class, this question was also done, right?
Yes.
Okay. So let us say skip this question and just remember this problem. Okay. So just remember that what we do in this problem. And the next concept that we learned was that if we have a dipole, so potential due to a dipole, right? So this is A, and we calculated at this arbitrary point, which is making an angle theta. So we calculated the potential. And what was the potential at P? Aisha, what was the potential at P for the dipole? Yes, what was the potential at P? Yes, remember, forgotten. Rabia, what is the potential at P due to dipole? Yeah, what is the potential at P due to dipole?
Sir, is it PK cos theta?
Yeah, so KP cos theta. Oh, so I should not write this. This is point and this is the dipole moment magnitude. Okay, so just remember Kp cos theta by r square. Yes, Aisha. Correct, absolutely correct. So this is the potential. I should not write this subscript, right? So this would be confusing with this P. Okay, so this is the potential of a dipole, right? And we see that this varies as 1 over r square. So what is the, okay, now let me again ask that this is, so this is what point? For this dipole, this is what point, Rabia? For this dipole, this is what point? Oh, who got disconnected? Rabia got disconnected. So Aisha, you remember what is this point? For this dipole, what is this point?
Axial point.
Axial point, yes, absolutely correct. So axial point and this is equatorial point. Right. So do you remember the electric field at the axial point? Axial point electric field was what? So this is the direction of the dipole. So axial, what this is what? This was what? Axial point?
2 kp by r cube.
Yeah, 2 kp by, good. So you remember 2 kp by r cube. And what was the electric field at the equatorial point? Yes. Yes, Aisha.
Minus kp by r.
Minus kp by r cube. Right. So for the case of equatorial, the direction of electric field was this, which is against the sign of this dipole moment. So P vector is in this way. So for equatorial, the electric field was this way and axial electric field was this way. Right. So you see that this is r cube and this is r cube. So for dipole, the electric field varies as 1 over r cube. Right. So this is electric field. This is how electric field varies, and this is how the potential varies for the case of dipole. And for the case of point charge, the electric field varies as kq by r square, right? And this is kq by r. So E varies as 1 over r square, and V varies as 1 over r for the case of point charge. Right, and this is dipole. So just remember these points. Okay. Yes, Aisha. Okay, so yeah, Rabia got this. Rabia has entered. So, yeah. Yes, yes, Rabia, you got disconnected. So we were discussing that this is the potential of a dipole, Kp cos theta by r square, right? And this is the axial point for a dipole, right, Rabia? This is the axial point, right?
Yes.
And this is the equatorial point, right? So for the axial point, this is the electric field 2 kp by r cube, and for the equatorial minus kp by r cube. This is the electric field for the equatorial part, right? So we see that what we see that electric field varies as 1 over r cube and 1 over r cube. So for the dipole case, the electric field varies as 1 over r cube and potential varies as 1 over r square. Understood? Is this clear, Rabia? Yes,
Yes,
understood.
sir.
And similarly, for point charge, electric field is kq by r square, and potential is kq by r. So electric field varies as 1 over r square for point charge, potential varies as 1 over r for point charge. So these are for the point charge and the dipole. Understood? Yeah, please note down this part. You guys, please note down this part. So just so that you guys don't forget this part. If we repeat again and again, then you guys will not forget. Yes, noted, guys.
Yes, sir.
And Rabia, noted.
Yes, sir.
Okay, so yeah. So again, let us come back to this point. So we have this minus q, this q, right? And we know that this is theta, and potential is kp cos theta by r square. So if I'm calculating the potential at this point, right? If I'm calculating the potential at this point, so what would be my theta? Yeah, what would be my theta at this point?
0.
0, right? So this is how my theta is increasing. So for this part, theta is 0, and this part, so at this is theta, which is axial point. So at axial point, my theta is 0. So V is Kp by R square. Right. V is Kp by R square. And at vertical point, equatorial point, so what is my theta, Rabia? At this point, theta is what? Yes, Rabia. Theta is what at this point, Rabia? Yes, Rabia, what is the theta at this point? Okay, there is a problem with your mic, or what is happening? Yes, Rabia, can you hear me? What is the theta for this point?
Uh, sir, I'm not sure.
Yeah,
Uh,
just take any guess. Okay.
180.
Yeah, so equatorial point is this point, right? This point is the equatorial point. And this was theta equals to 0, but you have come at this point. So this is what angle?
90. 90
90, right?
degree.
So this is a 90. Yes, correct. So theta would be 90 degree at equatorial point. Understood? Yeah. So cos 90 would be how much? Cos 90 is how much? Rabia, cos 90 is how much? Yes, Rabia. Cos 90 is how much?
0.
0, right? So V at equatorial point would be how much? Kp cos 90 by r square. So this is 0, so 0. So at equatorial point for dipole, potential is 0. At axial point, potential is Kp by r square. So you guys please note down this part. This you have already done in your CBSE classes. but I just wanted to repeat that for you. You guys quickly note it down. Yeah, noted, guys. Oh, I just told you to note it down. Yeah.
Done, sir.
Done, Aisha, done.
Done, sir.
Okay, so we have only 3 minutes, but we have this question. So what I will do is that I will do this problem in the next class. So the question is that what is so we have two dipoles of let's say two dipoles. Let's say this is dipole 1, right? So this is of minus 4 AQI hat, and let's say dipole 2, right? This is of minus 2 AQI hat is placed, or two dipoles are placed on the x-axis. Find, okay, let's say that this is A and B. So find the distance from A where potential due to A and B is same. Okay, this is the question. So you guys note down this problem, and this we will do in the next class. Okay, guys.
Okay, sir.
Yeah. So you guys think about this problem, and in the next class we will do this problem. Okay, guys. Bye, guys, and all the best for tomorrow test. Okay. Yeah. Bye.